So they said you could do a lightning talk. So I was like, oh, okay. So I'm Joe Speed. I'm pretty easy to find. You can just Google whatever. DM on the normal platforms and what have you. So I'm going to talk about Nix development to go. So I work for a company called Ampere. We make ARM chips. So like this is your basic 192 core ARM CPU. And so they're super fun. Most of what we do is cloud, but I'm the guy that doesn't have to worry about cloud. We have enough people that worry about cloud, so I do all the 5G, autonomous vehicles, Ampere in space, work stuff with you guys, all that. So that's us, right? So more cores, less power. Gearlink says cores are the new hertz after getting hold of some of our gear. Something. And so whatever your size, weight, and power, we give you more compute for that, yeah? And then Next Computing, so they make this rig over there. So that is a carry-on suitcase with a lot of compute. So, yeah, that's fun. So one of the things I noticed working at Ampere is there's not a lot of good options for ARM developers. There's kind of like Pi, and then there's Apple Silicon, but if you want to like add more memory, your own storage, you want to plug in PCIe devices, your options are pretty limited. So I work with these blokes, System 76, so they make some gear, and apparently Gearling likes it. Window at Level 1 Tech has some opinions as well. Yeah, so that's that. So this thing over here, it's your basic carry-on Nix universe build farm, okay? So this one they have is like kind of mid, right? It's got just 384 cores, same amount, 384 gig of memory, like 18 terabytes of storage. It's got, I guess, 6 10 gig E, and it also has a RTX 4000 ADA GPU. So, but they can go a lot bigger, a lot more powerful than that. But it's TSA approved, right? So this is great. Like, we didn't develop it just for you guys. Like, it's a cyber threat response team kind of thing where they need to just get on the next commercial flight instead of a non-commercial flight, I guess I would say. But you could do a lot with it, and it's like, we're ARM based, so our party trick is whatever Intel does, we using 1/4 of the power, which means for the same power TDP, you can put 4 times as much compute. So that's what makes this thing work. And you can get it with like 4 nodes. I just realized I didn't ask them if I could tell you like their new stuff, like how much is in it. So I'll just say hundreds of cores, more than a petabyte of fast flash NVMe, and so on. And so from here, it's going to go to NixCon in Switzerland. So they're going to do stuff with it as well. And it's 3 nodes. The most powerful node, so one of the nodes is named, actually, what's the question? So question for the room, why is the main node named Saitama? Exactly. So that's the most powerful of the 3 nodes. So, yeah. So that's fun. So things you guys can do with this kind of stuff. And besides like Next Computing and System 76, they keep selling out, but I did a nice price bundle on Newegg, so you can like build your own. And if you go to the community.amperecomputing, there's like guides and contests and things for people who have done their own home builds for Home Lab. But you can do a lot of stuff with this, right? So you can build and test ARM on the same platform. You don't have to use emulation, right? You can use GPUs, PCIe and such. It's pretty performant, like, think in terms of, like on the one Tristan has at home, 66 Linux kernel builds per hour, yeah? And the Ampere 1 stuff is like a lot more, like double, something like that. Automakers and folks like this, because they can do CI testing, so what they actually do is they set up virtual ARM SoCs, okay, but they're virtualized, not emulated, so they're quite very performant. And so like on Ampere 1, you can run 48 4-core virtual ARM processors SoCs at full tilt. And so here's a little bit of performance compare that who's heard of Jeff Geerling? Is this okay? Okay. So like Geerling did some testing of this. So this is just a little stupid script. It runs CoreMark, which is used a lot of embedded systems, like just to get a sense of processor performance. And so it spins up a large number of, on ARM, it's QEMU KVM, so virtual, okay? On x86, it's QEMU emulated. And you can see, like, if you were doing CI testing, you know, it makes, like, for all you, this is an obvious thing, right? Like, oh, if I develop ARM software, maybe it would be good if I test it on ARM, right? But you would not, automakers have entire data centers of, like, Intel servers running QEMU and other emulators to test the 100 million lines of code that are in your car, right? Like, there's gotta be a better way. So this is a fun one. So Lars, he just sent this to me last night. So he was doing a science project with one of our computers for this Nerve IoT hub stuff. So it's like this Erlang thing for IoT device fleet management. And he spun up 5,100 virtual ARM devices running in concurrently. So that's fun, yeah. And then this is something else. This is one of my pet projects. Carnegie Mellon said I could tell y'all. So NSF just approved like yesterday, a concept for proposal for what you do is you take that flyaway kit, and so now these days with in 5G you have this thing called ORAN, Open RAN Radio Access Network. So it's basically like a completely open software stack for 5G base stations. So what you can do is you can run that on a bunch of the cores. You can also run AI inference like YOLO on the other cores, and you can turn the whole thing into a carry-on 5G base station and AI compute mech, okay? And the thing that's clever about this, what CMU is doing, is that it turns out putting AI in drones is expensive, right? It costs money, it costs weight, and because of the power demands, it costs you flight time, okay? But having drones stream video over 5G is cheap. You can just use like commodity consumer drones. So that's something we're doing too. And that's my talk.